Hello everyone, good morning. I am Mahalakshmi B, Assistant Professor in Physics, Hindustan College of Engineering and Technology, Coimbatore. I am here to introduce a few topics on properties of matter, including elasticity and elastic materials. The objective of this video is to say about elasticity, plasticity, stress, strain, definitions and types, Poisson's ratio, Hooke's law and stress strain diagram. What is elasticity? Elasticity is the property of solid materials to return to their original shape and size after the forces deforming them have been removed. Examples are shock absorbers of vehicles, natural rubber, metallic wire and stainless steel. Here is the diagram showing the examples of few elastic materials like rubber band, springs which elongate when they are stretched. Now let us see what is plasticity. If the body does not regain its original shape and size when the applied force is removed, then it's a perfect plastic body. This property is called plasticity. Inelastic or plastic bodies, examples are the bodies like chewing gum, lead solder, putty duff, that is wet mica and wax which get permanently deformed under the action of even small forces are called plastic bodies. Now let us see the definitions for stress, strain and elastic moduli. The stretching, squeezing and twisting a real body causes it to deform as shown in the figure. We shall study the relationship between the forces and the deformations as they cause. Now let us see what is stress. Stress is the force per unit area and strain is the fractional deformation due to stress. Elastic modulus is stress divided by strain. Stress and strain. Stress refers to the cause of a deformation and strain refers to the effect of the deformation. The downward force F causes the displacement X when we pull the spring in the downward direction. Thus, the stress is the force and strain, that is increase in length from its original length, is called the elongation. Then let us see the types of stress. Normal stress and tangential stress. Normal stress is the stress with force acting per unit area perpendicular to the surface. Normal stress is equal to F normal divided by area A. Tangential stress. The force acting per unit area parallel to the surface. Normal stress will be perpendicular to the surface, whereas tangential stress will be parallel to the surface. Tangential surface is stress is equal to Ft, that is tangential stress which is equal to Ft tangential force divided by the area A. Strain. The ratio of change in dimension of a material to the original dimension is called strain. Strain is equal to the ratio between change in dimension to the original dimension. That is, epsilon is equal to E divided by L naught, where E is the elongation in meter, L naught is the unloaded length, that is original length, and original length of a material, and L is the elongated length of a material. Now let us see the types of strain. Longitudinal strain or linear strain, that is longitudinal strain is equal to change in length small l or divided by original length capital L. Then shearing strain. Shearing strain is equal to angle of shear theta, and the third one is the volume strain. Volume strain is equal to change in volume, that is small v divided by original volume capital V. Poisson's ratio, that is definition is within the elastic limit the lateral strain is proportional to the longitudinal strain. That is the ratio of the lateral strain beta and a longitudinal strain alpha is a constant for a given material. This constant is known as Poisson's ratio. Lateral strain, that is, definition is whenever a body is subjected to a force in a particular direction, there is change in dimensions of the body in the other two perpendicular directions. This is called lateral strain. That is, sigma is equal to beta by alpha, and alpha is equal to change in length divided by original length. Therefore, beta is equal to change in the ratio between change in diameter, that is delta D, to the original diameter D. Now let us see about Hooke's law. What is Hooke's law? This law was proposed by Sir Robert Hooke in the year, his period of time is 1635 to 1703. In English, the biology, the cell was discovered by him, and chemistry, vacuum, the concept, and the Boyle's law was proposed by him. Physics, refraction and wave theory of light, gravity, and law of elasticity are some of his inventions in the various fields like biology, chemistry, and physics. Hooke's law states that within the elastic limit, the stress developed in a body is directly proportional to the strain produced on it. That is, stress is directly proportional to strain, or stress is equal to some constant named E into strain, where E is equal to the ratio between stress and strain, and that constant E is called modulus of elasticity, and it's expressed in mathematically. This Hooke's law is F equal to minus kx, where F is the restoring force of the spring and x represents the distance that the spring has been stretched or compressed from equilibrium, and k is the spring constant. Negative sign represents the force which acts in opposite direction of the displacement, and here is the figure depicting the spring which is being elongated when it is pulled by a force F. Let us see the types of moduli of elasticity. That is, Young's modulus of elasticity Y, rigidity modulus of elasticity eta, and bulk modulus of elasticity, which is denoted by K. Let us see what is Young's modulus. Young's modulus is equal to the ratio between normal stress to longitudinal strain. The unit is Newton meter per minus 2. And rigidity modulus of elasticity denoted by eta is defined as the ratio between tangential stress to shearing strain. Its unit is Newton meter per minus 2. The next one, bulk modulus, is defined as the ratio between volume stress to volume strain, that is change in volume to the original volume. Its unit is also Newton meter per minus 2. So let us now depict this Hooke's law with a small example, that is extension of springs. How to find the extension of a spring? It's where original length is L, normal length, then that is also called normal length. Then there is an extension in the length of the spring when it is loaded at one side by masses connected to a holder. So extension is equal to the original length minus the normal length. When the force is doubled, the extension of the spring is also doubled. It also shows that when the force is halved, the extension of the spring is halved. This means that extension is proportional to the force added. This relationship is called Hooke's law. Let us see about stress strain curve. So the following curve, this curve below depicts the relation between stress and strain. So there are four stages. Here when the body is loaded, the change in shape of the material extends in four phases from OA, then AB, then BC, then CD and DE. So these are all the stages that the material undergoes when it is being loaded. So A is called the proportional limit, that is the region which obeys Hooke's law. The straight line OA is the region of proportionality, that is the body extends in length when it is being loaded and regains its original shape when it is being unloaded. So it is called the region of proportionality. So within this proportional limit, the body obeys Hooke's law, that means it remains elastic in nature. Then B is called the point elastic limit, that is the maximum stress up to which the body exhibits the property of elasticity is called elastic limit or limit of elasticity. So beyond the point A, the stress and strain stop to share their linear relationship. That is, the body doesn't obey Hooke's law, but the material manages to retain its elastic property. The point C is called yield stress point. That is the point at which the material will have an appreciable elongation or yielding without any increase in load or stress. The point at which the material starts to deform plastically starts at the point C. Point D is called ultimate stress point. That is the point at which the material can handle maximum stress before breaking or failure. The wire begins to flow locally if loaded so that its cross-sectional area gradually decreases. Then the point E is called breaking point. That is the point at which the failure of material takes place. The point at which the strength of the material breaks and the stress associated with the point E is called breaking strength. And the figure also shows the stress strain relationship for a material called A36 steel, where the different points like proportionality limit, elastic limit, yield point and the breaking stress are shown in stress and strain relationship. Thank you for the patient listening. Thank you again.